Hello, and welcome to a new HiQ Tech Talk. My name is Johan Sandeblad, and I work with innovation projects at HiQ. For the past 3 weeks, I have been using Apple's latest M1 laptops for my daily work, spending time with Xcode, Python, Photoshop, Final Cut, DaVinci Resolve, Microsoft Office, and many other applications. And for me, the experience has almost been shockingly good. My previous laptop was an almost fully maxed out 8-core MacBook Pro costing over 50,000 kronor here in Sweden. And Apple's newest laptop starting at just 12,000 kronor beats this laptop on every single task I throw at it. And looking at YouTube, fact is that this new 12,000 kronor laptop even beats fully spec'd out Mac Pro computers, costing over 200,000 kronor in tasks like software compilation in Xcode. So, how is it possible that Apple can launch something for 12,000 kronor that can perform better than any of the other computers, even those costing nearly 20 times as much? To answer that, we need to go back a bit in time to the point when Apple did the exact same thing once before. In 2007, when Apple launched the first iPhone, I remember looking at the presentation and wondering if it was all fake. Back then, the most advanced handheld devices were running an operating system called Windows Mobile, and everything shown on the screen was rendered using the CPU writing directly to the frame buffer memory of the display. Before the iPhone existed, I had created my own game development platform for mobile devices called GappyDraw, which I sold to companies like Skype, Sony, Nokia and Microsoft. So I had a fairly good view of what one can expect from a mobile device in terms of visual performance. And overall, it was not so good. Since the CPU had to do all the drawing to system memory, animations were few and slow. Using my highly optimized game development platform written in C++ and assembly language, it was actually possible to develop games that looked and performed pretty well. But the operating system was more or less a disaster in terms of visual performance. And then came the iPhone. How on earth could Apple get such amazing visual performance in a device that was so small? Compared to Windows Mobile devices, the flowing animations of the iPhone looked like they came from another world. What was the secret that meant that Apple could leapfrog the entire competition in this way? According to Apple, the iPhone was at least 5 years ahead of any other smartphone on the market. And looking at it in retrospect, they were absolutely right. Suddenly, all other handheld devices and smartphones did not appear to be smart anymore. Apple's big secret was in a newly developed chip that combined a CPU, a GPU and a unified memory architecture into one single and very powerful chip, also called System on a Chip. Also, Apple had built a new operating system called iOS from the ground up to take advantage of this new architecture, and could implement things like fluid animations all over the interface thanks to this new hardware. And after the first iPhone launched in 2007, Apple has continued to improve this concept by increasing the performance of both the CPU and GPU in their chips, but still keeping it as a single system on a chip, including the unified memory. Now, back to the M1 laptops of today. Before the Apple M1 was released, almost all laptops and desktop computers were built the same way. A central processor, CPU, is responsible for running all the code. A graphics processor, GPU, displays all the graphics, and system memory, RAM, is shared across all components. This means that even if the CPU and the GPU are blazingly fast, they still have to rely on the slow system memory to communicate with each other. Also, data has to pass through the slow PCI Express bus on every time something needs to be shown on the screen. For use cases like gaming, this is mostly fine since games can stream data slowly in the background and fill up the dedicated memory of the graphics card. For other tasks like image editing, data has to be transferred in real time between the CPU, system memory and the graphics card when you work, which means that latency and performance will be limited based on the speed on your system memory and PCI bus. Smaller laptops typically have what is called built-in graphics, which means that the CPU also have a GPU built in. This built-in GPU does not have its own memory, but must rely on the slow system memory for all operations. To make matters worse, the built-in GPU is assigned a dedicated chunk of the system memory and cannot access other memory, which means that the CPU has to copy all data that the GPU requires from the slow system memory to the graphics card portion of the slow system memory. This is why built-in graphics is so slow today, and why it never really took off in performance. I have been mentioning M1 a lot, but what exactly is the M1 inside these new Apple computers? The M1 is a complete computer system in one single chip, a system on a chip, much like the iPhone and the iPad. The M1 has a CPU, a GPU, an image processing unit, a digital signal processing, a neural engine processing unit, a video encoder, a video decoder, a secure enclave, and a unified memory, all within one single chip. Much of the performance improvements we see with the M1 compared to other laptops is the use of what is called unified memory. This new unified memory is unique since the same memory can be used by both the CPU and GPU without copying needed. This makes the unified memory of the M1 more comparable to the specialized memory of a GPU than the old and slow system memory in today's PC systems. In fact, with solid-state drives reaching about speeds around 3 GB per second and improving every year, solid-state drives are likely to become the new system memory of all new Mac computers. So don't judge these new M1 systems based on the fact that they only have 8 or 16 GB of memory. This is not the same kind of memory you have on your old computer. Look at it like you have 8 or 16 GB of specialized video memory or cache, and you have several terabytes of system memory on your solid-state drive. If the M1 with its unified memory architecture sounds like the future of computing, then when will we see PC manufacturers develop their own system on a chip? The thing is that it might not be possible at all. The business model of Intel and AMD is to sell general-purpose CPUs that people can put on large PC motherboards. Computer makers can then simply purchase motherboards, memory cards, CPUs, and graphics cards from different vendors and put them into the same chassis. If one of the major computer vendors, such as HP or Dell, would instead want to go the system-on-a-chip route and create their own M1 chip, they would have to license the intellectual property for how to build these chips from companies such as Intel, AMD, and Nvidia. But they aren't going to sell it, since this is the core business. So that leaves the processor makers like AMD or Intel. Would they be able to make something that matches the M1? The main problem with creating a system on a chip like the M1 is that it's difficult to create lots of variations. For example, maybe someone doesn't need a graphics card for a server and do not want to pay for it. Maybe another one doesn't need specialized chips for video decoding, or the secure enclave for real-time encryption. Intel and AMD would end up with hundreds, if not thousands, of combinations to meet the demands of corporate users that want to keep the price low and not pay for things that they don't use. Also, even if they were to create their own system on a chip and maybe put a neural engine in it, who could use that engine? Specialized drivers would have to be created for Windows, and software developers would have to create code specifically for these unique systems. Apple, on the other hand, they create computers for creative professionals that can afford to pay extra for features they might not actually use. And Apple can add support for features like Core ML to the operating system, and developers can easily use it and expect it to run on all Mac computers, no matter if they have a neural engine or not. It will just run faster on the M1 chips. This is why it makes sense for Apple to create the M1, but not for chip manufacturers like AMD or Intel, or computer manufacturers like HP or Dell. But it's not just the unified memory architecture that makes the M1 chip great. The past few years, the speed of CPUs have not increased by much. Instead, to improve performance, manufacturers have been adding more cores to each CPU so operations can be handled in parallel. For things like 3D rendering and operating on large amounts of data, this works very well. But for things like computer games or nearly any other desktop application, the performance does not scale well with the number of cores. Developers have to write code specifically to distribute the workload across multiple cores, which is difficult. And for some applications like music productions, where music channels are linked in groups, there are so many dependencies that having faster cores is often preferred to having more cores, especially when you compare a 16-core system with a 32-core system. What Apple did with the M1 and its CPU cores, called Firestorm, is nothing short of remarkable. Instead of adding dozens of cores or trying to increase the clock speed with a significant increase in heat as a result, Apple designed the Firestorm cores to handle more instructions in parallel. By using a technology called out-of-order execution, the M1 cores can execute more instructions in parallel without exposing it as multiple threads. For developers, they don't need to code their software specifically to handle out-of-order execution. To them, it just looks like each core runs faster. How it works in practice is that the CPU retrieves hundreds of instructions at the same time, and then analyzes them to see which ones it can run in parallel. The way the M1 performs this parallelization is unique, and the main reason why M1 cores are faster than any other low-powered CPU currently on the market. How long will it be before AMD and Intel copies Apple and implements the same type of parallelism in their chips? Well, it is not even sure it can be done. The Apple M1 uses a computer architecture called RISC, where each instruction is always 4 bytes long. On x86 chips, AMD and Intel, each instruction is between 1 to 15 bytes, and the CPU has no clue where the next instruction starts. So the x86 CPU has to analyze each instruction in order to see how long it is before it can fetch the next one. The way x86 chips handle this today is that they brute force and try to decode instructions at every possible starting point, resulting in lots of guesses and mistakes. This approach is in fact so convoluted that it's hard to add more than 4 decoders currently in the x86 chips today from AMD and Intel. The Apple M1 Firestorm cores, on the other hand, have twice as many decoders, 8, and can essentially process twice as many instructions at the same clock frequency as x86 chips. Currently, the only CPU core that is faster than the Firestorm on any computer is the AMD Zen 3, which is just slightly faster than the M1 Firestorm. Looking at the details, however, the Zen 3 is clocked at 5 GHz, where the Firestorm is clocked at 3.2 GHz. So despite having almost 60% higher clock speed, the Zen 3 is just slightly faster, with much higher power usage, where the M1 chip can run high CPU loads even without a fan. Is there anything AMD and Intel can do to improve their performance and be comparable with the M1 CPU then? Unfortunately, not so much. While they can continue to raise the speed of the cores slightly and continue to add even more cores to each chip, the cores themselves will not run much faster, which means that the desktop performance of AMD and Intel chips will not improve so much. The M1 chip is also built using the absolutely latest 5nm technology, which provides less heat, where Intel just announced that they cannot launch 7nm production until 2022 at the earliest. And changing to 7nm only means that they can push up the clock frequency while keeping the power usage the same as today. My guess is that in 2 years' time we will have desktop computers from Apple that will be 5 to 10 times faster than a comparable PC, with much less power consumption and heat. But for PC users, does it really matter? Apple M1 chips will only run macOS, and if you have to run Windows, then you still have to continue using AMD or Intel chips. Finally, Apple has added some extra code in the M1 chip to make it run legacy application built for the x86 really fast. The main difference between ARM and x86 processors is that they have what is called a different memory ordering. So, for an ARM processor to make sense of any data that has been stored by an x86 computer, it has to basically go through each and every memory block and rearrange its contents. This is why running Windows x86 applications on ARM tablets is so amazingly slow. Apple has added specific mode to the M1 chips that basically switches to the mode of the CPU into Intel memory ordering when running translated x86 code. This makes it possible to run emulated x86 code at very high speeds, often performing better than running the exact same application on previous generation x86 hardware. So, I hope you got a better view of the M1 and why I believe it's revolutionary and not evolutionary. The M1 will bring a new era of computers that will be completely unlike any other PC on the market, and they will only run macOS. So, should you buy one? If you're a developer and you're working with virtual machines and Docker, you should not upgrade now. This is simply because Docker is still not available for the M1, and even when the first release becomes available, it will probably take several patches before it's stable. Most software that have not been specifically compiled for M1 chips are run on the simulation called Rosetta 2, where the applications on the first launch are recompiled for ARM instructions. Virtual machines, however, cannot run on the Rosetta, so this is why you should wait if you depend on these technologies. Some virtual machines, such as the Android emulator shipping with Android Studio, has been updated, but there are lots of issues in the first release, and it will probably take weeks, if not months, before all are fixed. On the other hand, if you are using applications such as Xcode, Visual Studio Code or Python, you should have very few if any issues. Some specific environments such as PyEnv for virtual environments does not work, but other environments such as Anaconda Python works without issues. Xcode running on the M1 is extremely fast. It's much faster than my previous 8-core MacBook Pro with 32GB of RAM. In fact, tests performed by other users have shown that the M1 is even faster at compiling code than the most expensive Mac Pro computer. Installing legacy software like CocoaPods works, but requires some modifications to the scripts. But today there are alternatives like the Swift package registry, which you should use instead, so mostly this is a non-issue. If you're using framework like MacBops, you're not able to run your application in the simulator until they have upgraded their SDKs. But until then you can run your code on the device just fine. In my tests, it takes less than a second before I click on the run button in Xcode before the application is launched on my iPhone, and I did not experience an iOS framework that did not run as expected when I ran the debugger on the device. Adobe has already updated Photoshop to run native on the M1, and it really flies on this new chip. Other tools such as Sketch has also been updated to run natively on the M1 with huge performance improvements compared to previous generation hardware. Premiere Pro from Adobe is not updated and runs very slow, so if you're using Premiere you should absolutely wait until it has been updated. And even then it might take several updates before it's fully optimized for the M1. To take full advantage of the unified memory and the specialized chips on the M1, it's not just enough to recompile the code. DaVinci Resolve 17 is one example where an app has been recompiled for the M1, but in my tests the performance playing back H.265 video in 4K was much worse than Final Cut Pro. So I guess it's a two-step process. First, developers need to get their software to run native on the M1, and then they need to get the software to take advantage of the unified memory and all the specialized chips in the M1 to really make it fly. The entire Microsoft Office suite has been updated for M1 chips and runs very well, but other applications like Teams and Zoom has not. And while Microsoft Teams runs on the M1 chips, it feels very slow and sluggish at times. Overall, however, the performance is good, and things will just get better as we move on. If you're spending your time in Chrome, you will be glad to hear that Google also fully supports the M1 chip, and Chrome is extremely fast on the M1 chip. Apple has added JavaScript optimizations straight into the chip, which makes this probably the best Google Chrome device you can buy, no matter what price you pay. And using online services like Figma or Miro, it really shows. Everything is very, very fast in Safari or Chrome on the M1 laptop. So, is it worth buying the M1 laptops today? If you're not depending on the Docker, virtual machines or Premiere Pro in your daily work, then yes, go ahead. These new laptops are much cheaper and much faster than any other portable computer today. In many cases, they are even faster than stationary computers, costing 4,000 to 5,000 much, and if you work with Xcode, they are faster than anything on the market, period. When the iPhone launched in 2007 and the App Store launched in 2008, I was more excited than ever about the future of mobile. What Apple had then was amazing, and you can expect it to become even more amazing in the coming years. With the M1 chip, I feel the same way but with laptops. This is an outstanding, amazing piece of engineering, and the only time will tell what amazing devices Apple will create based on it the coming years. This was all for me today, and I hope you learned something. The next time you will hear from me is in January, where we'll show how spatial audio works on the new AirPods Max, and how you can develop applications that take advantage of this new technology for user interaction. Until then, goodbye.